I'm really concerned about the Internet of Things, and we connect everything to everything, and we don't understand the dangers, we don't understand the risk, and we need to.
Hi, my name's Stephen Lamarca with IMTSTV. I'm sitting here with Perry Pederson of the Langner Group, and we're at MC2 2016 in Dallas, Texas. All right, Perry, so we just finished. Let me get my questions up here. Promise I'm not texting like one of these millennial degenerates. I got my questions. All right, so I'm very curious. Langner, they broke the code with Stuxnet. Can you tell me more about that?
Yes, as you may know, the virus was actually discovered by another company, Symantec.
Right.
But when they discovered it, they didn't really know what they had. They had to Google PLC, which stands for Programmable Logic Controller. So they didn't know what the core piece of what the Stuxnet weapon was really doing. They knew it was bad. They knew it was a virus and it was propagating, but they didn't really know what it was doing. And this is what my partner, Ralph Langner, did, was tore apart that payload of that cyber weapon to figure out what it was doing.
More of a basic question. What's the difference between cybersecurity and cyber-physical security?
One of the basic differences between cybersecurity and cyber-physical security is this need to understand context. In other words, it's the process that's being controlled that is the concern, not so much the device itself. On the IT side, you're trying to protect computers, you're protecting information. On the OT side, on the industrial side, you're protecting the process and the integrity of the product. And in many cases, we're not dealing so much with malware, but we're dealing with features of these control systems that will never be turned off, they'll never be patched, and they won't go away. So you have to figure out another way to do it that doesn't entail just antivirus and firewalls and things like that.
So can you expand upon cyber attacks or threats that don't involve malicious programming?
Yes, well, as I was just talking about features, this is what I'm most concerned about on this side of the cyber-physical equation. For example, back in 2007, when I managed the Aurora test, when I was at the Department of Homeland Security, this was a case where malware did not destroy that generator. It was simply the commands that were used normally by the engineers in the field. But we used those commands with malicious intent. So that's the difference. Okay. It wasn't malware per se, but it was the feature of the system that was simply used against the system.
Oh, somebody in your talk actually had a great question, and I'd like to expand upon it by asking, what's the difference between IT and OT?
Well, IT, of course, everyone thinks they know IT, right? It's their handheld device, it's the Wi-Fi network, it's the computer at your desk, it's the server in the next room, it's the World Wide Web. So everyone has at least some idea of what IT is. OT, on the other hand, is what's happening in the background and nobody sees it. For example, the electricity in this room, the heating and air conditioning system, it's really transparent. It's operating, we know it's working, but we really don't know how. It's the insides of those kind of systems where controllers do their magic. And this is the difference. It's the interface to the physical world. This is what makes it different, because it not only can change and impact information, but it can actually impact the physical world. Like a malicious hacker could break into the system in this hotel and crank up the heat and lock all the doors. And that would not be very comfortable.
No, not at all.
Or they could get into that system and use that as a pathway to then maybe get into the IT network. So the real difference there between IT and OT is the connection to the physical world. IT, not so much.
Okay. So has the Langner Group done anything in cybersecurity and cyber-physical security with respect to the Office of Personnel Management's cybersecurity strategy and implementation plan?
No, other than read it, like most people have. There's a very small part of that that really deals with industrial control systems or OT systems. Most of it is focused on IT. And when you look at the OPM breach, for example, that was an IT issue. That was not a cyber-physical problem. But the plan that's coming out is focused on that, and it's focused a lot on information sharing. This is one of the pitfalls that I believe exists in this approach, is by focusing so much on sharing threat information, perhaps asset owners are really taking their eye off the ball. And by that I mean the ball is their own system. Instead of fixating on the horizon at the next threat and what's coming and how fast can I share that threat information, perhaps I need to do my homework. Perhaps I need to focus internally and get control of my own system, understand it fully, manage it completely. Those are the things that I think are more important to do than sharing information that for most people has no bearing. For example, a new threat emerges and the government wants companies to share this information at machine speed. So first of all, does that threat have any impact on your systems? And the only way to answer that question is to know what you have. So if you don't have a complete and accurate inventory to start with, you don't even have the correct framework to be able to assess threat information, whether it's relevant to you or not.
All right. Yeah, one of the reasons why I bring that up is in your presentation, you mentioned Battlestar Galactica, and the one human base that survived was the one that was not up to date. And in fact, the OPM was breached because of something simple as they weren't up to date. So that something that could have prevented that attack was a simple patch.
Again, that kind of illustrates the difference between the OT and IT side, where on the IT side, you might consider that the risk goes up as the systems get older.
Okay.
And they're not patched, and they're out of revision, and they're not updated, right? So on the IT side, that risk might even increase as those systems get older. But on the OT side, it's kind of the reverse. It's the old systems that don't get updated, that are perhaps still analog for the most part. Those are the things that I worry about less. For example, nuclear power plants in the US today, most of the safety systems in those power plants are still analog. There's no software. You can't lie to them. They're based on physics. They work. You can't hack them. They're not hackable. There's no software. If there's no software, there's nothing to hack. So those are instances where, again, it shows that difference between the IT and the OT.
Cool. So it's not just something like that, it's not that it's air-gapped, there are no computers controlling it?
Correct.
Okay.
Yeah, and air gap is another one of those things that some people think it provides them security, but it really doesn't. Because even an air-gapped, isolated, standalone system still has to be updated, patched, has to be installed initially, right? All these things have to happen somehow. So something has to jump that air gap. whether it's a USB stick or a laptop or a test equipment or something. So not that an air gap is completely ineffective, it does give you something. It's just never the total solution.
And I almost forgot, you brought this great hat for us here. Could you explain the significance of this?
Yes, I had this idea in watching the current political circus that's going on in this country, but what struck me is how this is connected with the idea of our company and what we're doing. This is really an effort to recognize that this cybersecurity is an engineering problem, and we need to make engineers great again, not by just saying they're great, but by giving them the tools that allow them to really manage their OT environments.
All right. Well, thank you so much, Perry.
Thank
This
you.
is Stephen Lamarca, IMTS TV. We'll see you next time.